So in this case, we are going to consider a typical exam revision as we are revising for our term 3. Okay, so that's KZN province, which we are going to work with. That was the Zululand district. So we're gonna see, guys, for our grade 9 mathematics. That was our September test, and we are given this one. It was 75 marks. Okay, so compared to some of the question papers that we have been attempting, we can see that this province, they've been trying to give a lot of questions. If we see the previous, it was 50 marks, 1 hour, but this was a 75 marks question paper, 1.5 hours. All right, so let's see. Anyways, make sure that you go through your instructions, read your instructions that you are given. This question paper has got 4 questions. Answer all questions, and all questions clearly show all calculations that you have used in determining your answers. All right, answer question 2 to 3 in spaces provided. All right, answer only answers, all right, or answer only will not necessarily be awarded full marks. Then diagrams are not necessarily drawn to scale. Question 3, question 4 are geometry questions. Make sure you state a reason for your answer, as marks are allocated for reasons. All right, where you are dealing with the geometry, make sure that you're gonna write or give the reason for the answer that you are going to give them. All right, so section A, question number 1, we were given 4 options are provided as answers to the following questions. Circle the letter corresponding to the correct answer, corresponding to correct answer. 1.1, the equation of the straight line given below is given that we've got our x-axis, y-axis, and this line is drawn crossing or cutting the x-axis and the y-axis. In this case, we've got our y-axis at 1, the x-axis at -1. What will be the equation? All right, remember, y is equal to mx plus c for a straight line, where m is the gradient. So you can have the gradient, the change in y over the change in x, as you consider the change in y over the change in x. Y as it is going down, that's from 1 to the origin. As you are going down, that's a -1. Over the change in x, we are going to the negative, that's a -1. So we had a gradient of what? Of 1. If you are using this concept, or you can obtain your gradient from points. The x-intercept, that's -1, 0 there, and the y-intercept, which is x is 0 there, y is 1. So these are 2 points that you're going to label x1, y1, x2, y2, so that we can determine our gradient. The change in y over the change in x will be written as y2 minus y1 over x2 minus x1. So thus we can substitute y2, which is 1, minus y1, which is 0, over x2, that's 0, minus x1, which is -1. So it is -1 like this. Okay, so that was going to give us 1 minus 0, which is 1 over minus minus, that's a plus. So 0 plus 1 is 1. So you're going to have 1. So as you can see, we've got the same gradient. It is up to you the way that you're going to have your gradient. So with that gradient, substitute it in place of what? In place of m. So that's y is equal to 1x plus the y-intercept, c, representing the y-intercept. Our graph crosses the y-axis at what? At 1. The y-axis, it crosses the y-axis at 1. So that's plus 1. So that's it. Y is equal to 1x. It is same as x. So that's y is equal to x plus 1. And for the answers that we are given, the best answer there was going to be B. Y is equal to x plus 1. You can use any way, guys, to determine the equation of a straight line. 1.2, the equation of the graph that passes through this point and this point is what? We're given 2 points. So simply determine your gradient x1, y1, x2, y2. So first the gradient change in y over the change in x. All right, so we're going to substitute y2, that is 3, minus y1, that's a 0 there, over x2, that's a 0, minus x1, which is 3 over 2. So that was going to give us the gradient. You can even use your calculator. Thus, put a fraction, 3 minus 0. So that's 3 minus 0 over what? 0 minus 3 over 2, like this. So that was going to give us negative 2. We have a gradient of negative 2. And of these points, we can see that the 0 minus the 0, 3, this one, 0, 3, this one, it represents the y-intercept. All right, in the y-axis, remember, x is equal to 0. Just like what we saw here, the y-intercept, it is 1, 0, 1. So with the y-intercept, you can just substitute it. In this case, our y-intercept, the graph that we're going to have, whatever the way that it was drawn is, but we know that somehow it was going to cross the y-axis at what? At 3, 0, 3. So that's our y-intercept. So therefore, we can have our equation straightforward from y is equal to mx plus c. M is our gradient minus 2x. All right, m being our gradient, which is the negative 2 that we calculated. All right, plus the y-intercept. So from the point 0, 3, from this point 0, 3, the y-intercept is what? Is 3. So that is y is equal to minus 2x plus 3. So the best answer is A, minus 2x plus 3. Okay, just like that. Then considering 1.3, the linear graph for the equation, all right, y is equal to minus 3x plus 6 is, all right, so of these, we are given the graph A, B, C, up to D. By just looking into these graphs, guys, we can see that the graph of C is automatically out. This one, it's a vertical line that we are given, all right? Remember, this is here 0, that is our x-axis. I want you to see something. This is section A, guys, where you're given answers already. So some answers, you can even get rid of them. The C, graph of C, is actually out because we do understand for this vertical line here, for this vertical line that we are seeing, its equation, just like the y-axis, x is equal to 0. So this one, where it crosses the x-axis, we can see that x is what? X is 2. So this is the graph of x is equal to 2. So it's totally out. The graph of C. Same as the graph of D, this one, x is minus 2 there. So this graph is for x is equal to minus 2. So we are left with these two graphs. This one of A and this one of what? Of B. Which one can represent this graph? The one that has got a negative gradient. As you can see, these two, they both are on, okay, here. They both cross the y-axis, the y-intercept here. The y-axis is at what? At 6. Both, they have the y-intercept. Y is equal to mx plus c, the y-intercept. Both are at 6. But which one can we say represents minus 3x plus c? The negative gradient, m, for lines with a negative gradient. When m is a negative, it means the line is supposed to be like this, negative gradient, okay? Where the change in y over the change in x. The change in y as you go down, it's a negative. The change in x is positive, so it will give us a negative gradient. So this is the type of a line that has a negative gradient. So which one of these, graph A or graph B that has got a negative gradient? It is graph A. As you can see, this one going this side. So this equation is best for graph A. All right, that's our graph A there, which has got a negative gradient. Okay, if it was a positive 3x, it was going to be for graph B, positive gradient. It means the steepness as it is going up, it's positive. Or you can simply sketch it, guys. As you do understand, simply find x-intercept and y-intercept. If you do not understand this way of getting rid of other graphs, therefore, just determine x-intercept. Just like the previous graphs that you had, there was another graph, okay, there was another part here where we were referring to the x and y-intercept. Just do like that. You can work it that way. Okay, so let's work that way. That's another way to determine our answer there. Since y is equal to minus 3x plus 6, we do understand that the x-intercept is on a condition where y is equal to 0. So find x-intercept and see what is your x-intercept there. When y is 0, place 0 there. So that's 0 is equal to minus 3x plus 6. Solve for x. Take the 6 to the other side, or take the 3x. The minus 3x will be a positive there. Okay, so if we take this minus 3x to the other side of the equation, it's going to be positive 0 plus 3x, which is what? 3x. So 3x is equal to 6. Divide by 3, divide by 3. So that's our x is 6 divided by 3. That's going to be 2. Our x-intercept is 2. The graph of y is equal to minus 3x plus 6. Its x-intercept is 2. As we can see, our x-intercept is here at 2 in the x-axis. The y-intercept, as we can see, the y-intercept is already there. Remember, C represents what? Y-intercept. Y-intercept is 6. Y-intercept is 6. So the graph that is going to be drawn after is what? Is graph A. With x-intercept being 2, y-intercept being 6, the graph is going to be this one. So our answer was going to be graph A. That is how you could have analyzed your answer to see if it is graph A. So many ways, guys. Or you can just figure out from the graphs that you're given which one. We can see this one is totally out, this one is totally out, this one is also totally out. Positive gradient. There we've got what? Negative gradient. So the best answer was going to be A. So many ways of attempting multiple choice questions, all right? On question 1.4, angles that are formed from perpendicular lines are what? If two lines are perpendicular, it means they meet at what? 90 degrees. So here they're saying these angles, they are acute. No, this is totally wrong. They are straight lines. They are corresponding angles. They are right angles, 90 degrees. That's a right angle there. All right, so the best answer was going to be D. And 1.5, what is the size of angle D? Angle D from vertically opposite angles, we do understand they are equal. So angle D is 60 degrees. Vertically opposite angles. So here we are talking about what? Vertically opposite angles. They are equal. On 1.6, if AB is parallel to CD, therefore the value of x is going to be what? X and 40 degrees from our corresponding angles where we form an F. One is inside of the parallel lines, one is outside. So as you can see there, we are forming F. So one angle must be inside, one must be outside. So X is what? 40 degrees. Thus, we are referring to what? Corresponding angles there, as these two lines are what? Parallel. All right, so the best answer there on 1.6 was going to be C. All right, let's consider 1.7. In fig below, we are told that AB is equal to AC. These two sides are equal. And also, AE is equal to AD, meaning to say, thus AE and AD, they're equal. The bigger one from A to B, from A to C, they're equal. Why are these two triangles ABE, AB to E? This triangle and ACD, these two triangles, why are they equal? Okay, so these two triangles, why are they equiangular? I mean, equal in terms of being congruent. Why are they congruent? That is exactly the same. All right, is it because of a right angle? Hypotenuse side? Is it because of side? Is it that is what is the reason that you can put into consideration about these two? If we check properly, we are already told that AB and AC is equal. Those are sides. Being equal, it is already given that these two, they are equal, the sides. And also AE and AD. Meaning to say, as we consider the triangle, we have got AB as a side. I mean, this AE and AD being equal. It's a side. So from A to B or B to A, here from C to A or from A to C, then we've got another side. But do we have any other side that we're going to consider? If we see properly, there is an angle A there. For both triangles, it is common. Angle A. It is a common angle, that one. Before we move to the sides that is AE being equal to AD given there. This one we are already given. Before we move to that, there is a common angle A there. So meaning to say, we can say these two, they are congruent because it's going to be side, angle, side. Side, angle, side. So we have got that one on A, side, angle, side. We cannot use 90. We cannot have side, side, side. No, we cannot have angle, angle. No. So the case of your congruence, the case or the condition of your congruence supposed to be from how you have obtained the two triangles that are given in that order. So you can work with the side AB or BA and AC, the common angle. Then we move on to those equal sides. So it will be side, angle, side. That is how we can attempt these questions. All right, let's see 1.8. We have got the two triangles are similar if. What is the condition for two triangles to be similar? Is it that all angles are equal? All angles are equal. When you say all angles, it is like from one triangle. If they use corresponding, the word corresponding, it can be proper. Not to say all angles. All is just like from one triangle, 60, 60 like that. That is not the case. So this one, the way it's given is not proper. But if you say corresponding angles are equal, corresponding angles are equal, which is actually true. From one triangle to the other one, this angle and this angle, this angle and this corresponding, if we put it that way, equiangular. Remember, they are equiangular. Corresponding sides are equal. It's not about corresponding sides, this one, but it's about the ratio, the proportion, not sides. Ratio of sides, not the sides. It is the ratio of sides which must be equal. Right angle, hypotenuse. Okay, this one is totally out. All right, so the correct answer there was going to be B. All right, 1.9, the property of a kite is what? All right, a kite, like this. All right, so all sides are equal. This is totally out. Two pairs of adjacent sides are equal. Remember, this side and this side equal, this side and this side equal. So those are Adjacent sides, those are properties of a kite. This one was going to work. Adjacent sides are perpendicular. These adjacent sides, where they meet at 90 degrees. No. This is wrong. Diagonals bisect each other. The diagonals, as we draw this diagonal and we draw this diagonal, do they bisect each other? No, they meet at 90 degrees, not to say they bisect each other. So this one is totally out. So the best answer was going to be B. All right, 1.10. We are given the property of a trapezium is what? A trapezium, remember, that one that is only one pair of parallel sides. All sides are equal. No, that is wrong. Diagonals bisect each other, these ones on a trapezium, that cannot happen. One pair of opposite sides are parallel. Only one pair. Only one pair. That is actually correct. Both pairs of opposite angles are equal. The opposite angles. No. This is for a parallelogram, not a trapezium. So this one is totally out. For a trapezium, it is one pair of what? Opposite sides parallel. Section B, on question number 2, we are given the graph. And on this graph, we can see that that's our x-axis here and our y-axis. So these were the values from the origin: 1, 2, 3, 4, 5, and so on. This is -1, -2, -3, -4, -5, -6, and so on. So from this graph that we are given, the question was determine the x-intercept from the graph. We do not even have the equation. We just need to look into the graph where it crosses the x-axis. So the graph crosses the x-axis at what? At 3. That's our x-intercept. The x value is what? Is 3 there. Remember, x versus y. In the x-axis, y is equal to 0. So that's 0 there. All right, 2.12, the y-intercept. As you can see here, it passes or crosses the y-axis at what? At -6, where it crosses the y-axis. This one, our y-axis, at what? -6. So that's 0, -6. That's 0, -6. Remember, in the y-axis, x is 0. So we have got the y value there. All right, so that was just to determine. You just look into the graph. You have got your answers from there. Then 2.2, determine the gradient of the graph below, 3 marks. All right, so there is a graph which is being drawn here. And on this graph, we can see, according to this, that's -1, -2, -3. That's -2, -4, -6, 8, -10. All right, so that's it. So we can determine the gradient of this graph here, as we do understand the gradient is the change in y over the change in x. So here the change in y going up from -6 going up, it means it's going to be +6 over the change in y going over the change in x, I mean, going to the what? To the left. That's -3 units going to the negative. So that's -3. So it's going to be 6 over -3, which is -2. All right. From the looking into of the graph, we just look into the graph and say, okay, this is it, guys. Change in y over the change in x, where we form what? A right angled triangle as we move like this. Or we can use points. We can use points another way. The gradient, truly it is the change in y over the change in x. Very true. y2 minus y1 over x2 minus x1. So let's have the points which are found on the graph. So the easiest way is to work with the what? Intercepts. We have got the y-intercept, we've got x-intercept. All right, so what's our x-intercept? -3, -3, 0, remember? And the y-intercept, 0, -6. So we can use points and determine our gradient. x1, y1, x2, y2. Then we can substitute these into our gradient formula. Y2 is what? Negative 6 minus y1, which is a 0 there, over x2, that's 0 minus x1, which is what? Minus 3. So this is what we have as our gradient. Minus 6 minus 0, that's minus 6. 0 minus minus, that's a plus. So that's going to be 0 plus 3, which is 3. So m is going to be what? Negative 2. The gradient of the given line. The gradient. Right? So many ways. On question 2.3, study the table below and complete the table to find the values of y. All right, and complete it. It was supposed to be just complete it to find the values of what? Of y. That is, as we are given, y is equal to what? 3x plus 8. That's our equation to be used. Substitute the x values in order for us to determine y there. So that's the first one, y is equal to 3 into x. What is our x? When x is minus 2 plus 8, just like that. So you substitute, then simplify. 3 times negative 2, that's negative 6 plus 8, which is going to give us what? Which is going to give us a 2. So that's the y value corresponding. So you're going to do this, guys. When x is minus 1, you do the same thing. In place of that x, you put negative 1. 3 times negative 1, that's negative 3. You add 8. That was going to give you a 5. All right, so that is it. You're going to obtain a 5 and so on and so on. So you put a 0. You put this 0 there in place of x. If you put a 0, 3 times 0, that's 0 plus 8, which is 8. You put a 1, you're going to get 11. You put 2 here, you're going to get 14. All right, or just use your calculator, guys, at once. Then with this, we can draw the graph as we are given on 2.32. They wanted us to plot the graph of y is equal to 3x plus 8. Y is equal to 3x plus 8. This one. That is the one that we have been working with. So already we have got this equation. So we have got the table. So using this table, you're going to simply mark the points, then draw the graph. So as you can see there, we have got up to 14. Yes, up to 14 in the y values. So I'm just going to try and use 2, 4, 6, because if you use 1, we're not going to win here. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So as you can see, we are ending up to 13. But there we have got what? We have got a 14. So in order for us to accommodate that 14, let's try to use 2, 4, 6. All right, so for the y values, we're going to use 2, 4, 6, 2, 4, 6, 8, 10. That's going to be 12, 14. So as you can see, we have got 14. We can accommodate the 14 there. Okay, so that is it. We do not have negative values there. For the x, we have got minus 2 up to 2. So you can even use 1, 2, 3. It's not even an effect there. You can even use 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay, it's fine. It's fine like that. So let's mark the points as we are given. The first one, minus 2 versus what? Versus 2. So this is minus 2 versus 2. X is minus 2. At that point, y is 2. So they do meet here. Where they meet, you mark a point. Minus 2 versus 2. We also have another point that we are given, which was minus 1 versus 5. X is minus 1, y is 5. Minus 1 versus 5 like this. Minus 1 where x and y is 5, in between 4 and what? In between 4 and 6. Where they meet, you mark a point. So it's -1, 5. Where they meet, you mark a point. So it was just going to be somewhere there in between -1 in x, 5 for y there. So 5 is found in between 4 and what? 4 and 6, as we have got our scale of 2, 4, 6. It's going to be in between. All right. Another one is 0 versus 8. X, there's nothing there. So go straight to the y value at what? At 8. In the y-axis at 8. Straight to the y-axis at 8. There you mark a point. That's the y-intercept of our graph. 1 versus 11. X is 1. Y is 11. 1 versus 11. So 11 is going to be between 10 and 12. So it's going to be 1, then 11 somewhere there. Where they meet, we must have a point. So it's in between there. So it's just going to be in between somewhere there. 1 versus 11. Then 2 versus 14. When x is 2, y is 14. As you can see, they meet here. Where they meet, we're going to mark a point. So those are the points that you're going to have as we are given from our table, and you join the points that's having what? A straight line. So that was going to give us a straight line at the end. All right, it's just going to be straight line like this. All right, remember here, some of these points, it was an additional part, so maybe it's going to be somewhere there. All right, so that's you're going to have what? A straight line representing the equation that we are given here. Y is equal to what? 3x plus what? 3x plus 8. So that's the graph of y is equal to 3x plus 8. So you just need your points. Remember on how to sketch your graphs. We referred to this one as a subtopic, as a topic on its own. So make sure you go through your introductions, guys, and understand how to attempt your questions. On question 2.4, draw the linear graph of this equation. Y is equal to half x plus 2. So you can use a table just like the previous question. Here you draw your table from any point of x that you want from these values that you're given, or you can simply use the intercepts. The intercepts, it is up to you. From the intercepts, we do understand when we are given y is equal to half x plus 2, we have got x intercept, where y is equal to 0 for the x-intercept. So y is equal to 0, you substitute that 0 is equal to half of x plus 2. So you solve for x. Take the 2 to the other side, it was going to be a negative. Negative 2 is equal to half x. You want to solve for x. So what can you do? Simply cross multiply. 2 multiplies here, 1 multiplies here. 2 times minus 2. That's minus 4 is equal to 1 times 1x. That is x. So your x-intercept is at minus 4, where it crosses the x-axis. It crosses the x-axis at what? At minus 4. So minus 4, that's here you mark your point. The same thing for the y-intercept. You do understand that the y-intercept when x is 0, or you can even look into your equation. Y-intercept what? 2. Y is equal to mx plus c, remember. C representing what? The y-intercept at 2. So the y-intercept in the y-axis at what? At 2. You mark the point. X-intercept minus 4, y-intercept at 2. These 2 points are enough for you to have a straight line, or for you to draw a straight line. So it is up to you. We are going to use points, or you're just going to work with these 2 points, x-intercept and what? Y-intercept. You're going to have the same line even if you decide to draw a table that you're going to have 3 or more points. or you just use what? These 2 points, the x intercept and y intercept. You can still have your graph x intercept, y intercept. So that's our graph of y is equal to half x plus what? Plus 2. All right, so that is it. Just try to do as many questions and different ways of answering, like try to figure out ways of answering. Determine the equation on question 2.5. You need the equation of this graph that is below in the form y is equal to mx plus c, provided that point A is 3, 4. The point A that we see on our graph there is 3, 4. Provided that this point A is what? Is 3, 4. Determine the equation of this line. So as you can see, the line crosses here on the origin, 0, 0. That's our y-intercept again, the origin. So what can we do? Determine the gradient as we are given in the form y is equal to what? Mx plus c. So m representing our gradient change in y over the change in x. y2 minus y1 over x2 minus x1. So you can label these points whatever that you want. You can have it as, okay, the way that you want, guys. You can have this as x1, y1. This is our x2, y2. So substituting y2, that's 4, minus y1, which is 0, over x2, that is 3, minus x1, which is 0. So that's 4 minus 0, which is 4 over 3. Okay, that's our gradient. The y-intercept, as we can see, the line crosses the y-axis. This is our y-axis. So it crosses the y-axis as what? At 0. At 0, at the origin. So our y-intercept is 0. C, the y-intercept. So therefore, the equation can be written as y is equal to mx. M, the gradient, 4 over 3x, plus the y-intercept, which is what? Which is 0. So that's y is equal to 4 over 3x. You can just even write it that way, or you can have it with a 0. It's up to you. You can just leave it like that. But these are the typical questions. They can ask you that way. Question 3, given below xy, we are given that xy and AB, they are perpendicular. They meet at 90 degrees. So determine with reason the size of XBA. Guys, already it's a 90 degree. So as we can just write XBA in that case, XBA, this one, the remaining angle from angles on a straight line, if you want to use that, 180 minus 90 degrees angles on a straight line, that's we're going to have what? 90 degrees. Guys, these ones are already perpendicular. We're told that they're perpendicular, so it will be 90, 90. There's no way. It will be 90, 90. All right. Then 3.2, AB intersects CD at X. Vertically opposite angles are formed, as we do understand. Vertically opposite angles are equal. So from that consideration that they do intersect at X, calculate the size of Y. Y in that case, all right? So that's vertically opposite angles there are equal. Y plus 30 degrees is equal to what? 87 degrees. Vertically opposite angles, remember. These are vertically opposite angles. So let's solve for y. Y is equal to take 30 to the other side. That's 87 minus 30. All right, so that was going to give us the size of y, which is what? 57 degrees. So where we see y there, that's 57. So that 57 plus 30 is 87. All right, vertically opposite angles. Question 3.3, we are given that in this figure that we have below PT, from PT, it is parallel to QS, right? These two lines, they are parallel, as you can see. Then their angles PQT, which is A plus 30, and angle T, which is A, angle RQS, which is 2A. All right, complete the table below to determine the value of A, and on that table they gave us 3.31 angle TQS for a reason that PT is parallel to QS and those are alternate angles, all right? PT being parallel to QS and we've got alternate angles like this, all right? So alternate angles here is going to be equal. Remember, alternate angles are equal. So that's the angle at T and the angle that is at Q. They're equal, this one, which is the one they indicated as TQS. TQS is also this one, alternate angles. So angle TQS is equal to A for that reason that you're given. So to find A, what can we do? We have got a straight line here, so we can use angles on a straight line, as we do understand that if we add all these, we must have 180 degrees, for a straight line. So let's use that one. So to find angle A, we're going to add the 2A. We add 2A, all right, plus A plus the remaining angle, this one, A plus 30 degrees. All right, A plus 30 degrees. We must obtain 180 degrees. That is for angles on a straight line. All right, so let's solve for A. As we can see, these are like terms. So you're going to have 2A plus A plus A, which is what? Which is 4A in that case. So this is 1, this is 1. 2 plus 1, 3 plus 1, 4. So 4A plus 30 degrees is equal to 180 degrees. That's 4A is equal to, take the 30 degrees to the other side of the equation, it was going to be a negative there. 180 minus 30 degrees. All right, so 180 minus 30, which is 150 degrees. So to find A, simply divide by 4 like that. So that's A is equal to 150 divided by 4. 150 like this divided by 4, which is what? 75 over 2, or 37.5. So that's 37.5 degrees. All right, just like that, you can obtain your angle A from the angles that are on a straight line. Form an equation from there, solve your equation. 3.4. In the diagram below, we are told that DF is a straight line. All right, DF. DF, this one is a straight line, okay? And also we're given that AB is parallel to PQ. AB parallel to PQ. And also EG is perpendicular to DF. EG is perpendicular to DF. That is, they meet at 90 degrees. So this is the piece of the diagram that we are given here. And from that information, determine on 3.41 the size of Y. All right, the size of Y. So where is it that we have got Y on our diagram? We can see that, all right, so that's 3.41. To find Y there, we can see here we've got a straight line. Angles on a straight line. DF is a straight line, remember? So we can add these angles. 3y minus 20 plus the 35 degrees plus the right angle there, which is what? 90 degrees. If we add these angles, we must obtain 180 degrees angles, what? On a straight line. So these are angles on a straight line. Okay, so let's have our y combined. All right, it's just y. It's just only one part there. That is 3y. Then combine these numbers, negative 20. All right, I'm just gonna combine this, minus 20 plus 35 plus 90 degrees. Just add That's 105. All right. So 105 is equal to 180 degrees. So we can take the 105 to the other side of the equation. So that is going to be a negative. That's 180 minus 105. So that was going to give us what? 180 minus 105. That's 105 like this. It was going to give us 75 degrees. So if 3y is equal to 75, what about the value of y? Simply divide by what? By 3. So that's our y value there. So y is equal to 75 divided by 3, which is 25 degrees. All right. So that is how we can play around. It's just issue of solving the equation now. We have formed an equation, so solve that equation. All right, another part was to determine the size of z, 3.42, size of angle z. All right, so as we have calculated the y value, remember we said our y value is what? 25. So what about z on 3.42? To find z, this is our z here. They are parallel lines. Okay, so let's try to figure out about these lines that are parallel. Okay, so many ways that we can use there. We can try even to work out with these C angles, which are co-interior angles. We can work out with corresponding angles. As we can see, we are forming an F angles like this. We are forming an F here. So we can even use corresponding angles as the angle Z will be equal to the one that is outside of the parallel lines. Remember, your F angles, one is inside, one is outside. So Z will be equal to the sum of these two, the 35 and the right angle, the 90 degrees. So that's 35 plus 90 degrees corresponding angles. As we are given that these two lines are parallel, AB is what? Parallel to PQ from that information. So that is it. We're going to have the size of Z, the angle Z. That's our Z was going to be 35 plus 90, which is 125 degrees. Okay. Then 3.43, the size of X. All right. So X in this case, we can see that our X here, that's our X. Remember, we determined Z. So to find X, there are so many ways. We can even use alternate angles. So many ways, guys. We can work with this one. As we can see, we are forming a Z. Alternate angles. We can use the Z that we calculated because Z is 125 and Z is here. So Z and X, they are on a straight line. So we can use angles on a straight line. This one, it was in your hands. So many ways of attempting that one. So I'm just going to use this one for angles on a straight line. All right, so that's 3.43. So X plus 125 degrees must give us 180 degrees angles on a straight line. All right, so there we are talking about angles on a straight line, angles on a straight line in that case. So let us solve for X by taking 125 to the other side of the equation. That was going to be a negative there. All right, so 180 minus 125, we're going to obtain 55 degrees. All right, that's the difference between these two. All right, so those are the lettered angles that we are supposed to determine. That's the Y, the Z, and also determining angle X. On question 3.5, in this diagram, we are told that AB is parallel to CD. All right, that's the AB and CD, these two lines, they're parallel. And also, there is PQ also parallel to RS and angle COS. This one is 124. Okay, that is it. Complete the table below to determine the size of the unknown angles. So on our table, there was the first part, 3.51 to find x. But the reason is given that these are corresponding angles where PT is parallel to QS. PT parallel to RS. This is supposed to be RS, isn't it? From here, PQ and RS. All right, that is what you're given there. PT and PT, this one, PT, RS. All right, let's just correspond. Let's just correct here. RS like that, all right? So X is equal to what? For these two to be what? Corresponding angles from these one. X and what? 124 degrees. Remember, corresponding where we form F. One is inside, one is outside. So that is the condition from our parallel lines. So it's supposed to be line RS there, all right? So that is 124 degrees. Okay, what about Y? The Y value there, all right? Remember, this is X that we have got here, so you can substitute that. Okay, let's see. X is 124 from those corresponding angles. Okay, so to find Y in that case, we can work with, there are a lot of ways, all right? We can find the angle T, or we can find this angle PTC, angles on a straight line. All right, let's just have this one before we move on to the angle Y there. We can say that this angle, as it is 124, it follows that this angle here is corresponding as 124 degrees. This angle, from also those parallel lines where we form F, one is outside, one is inside. So the angle here is 124 degrees as well, corresponding angles. Corresponding angles. So to find Y, we can use 180 minus 124. We can use 180 minus 124 for angles on a straight line. We can consider alternate angles if you have maybe calculated this angle here at T. Angles on a straight line. You calculate angle PTC, angle PTC. 180 degrees minus 124 degrees, angles on a straight line. All right, angles on a straight line. You can use that consideration. This is going to give us 56 degrees. So with this 56 degrees, we can consider to say it is an alternate angle to what? To the Y that we want. As we see these lines, we are forming a Z, alternate angles. So we can use that consideration to say, therefore, angle Y is equal to 56 degrees. Alternate, these are alternate angles. As we have got our C, this whole line of CD being parallel to what? To AB, or AB being parallel to CD. Alternate angles can be used, right? Where we form a Z. Z is being formed there. What is it that you're forming? All right, so that is it about angle Y, or you can use angles on a straight line. You can use corresponding angles. Still, you're going to have the same answer of what? 56 degrees. So there you had a lot of options to answer this one. Then angle Z, we can work with the Z from the 56 degrees, alternate angles from that way. So Z is equal to 56 degrees, alternate angles from these two lines that are parallel, PQ, alternate angles, as we have got PQ being parallel to RS. Or we can use angles on a straight line. We can use that, angles on a straight line. So many ways that we could have attempted this. We're still going to have 56 degrees. So guys, Just try to work out with your understanding and see if you're going to have the same answers there, because as long there is a reason, as long there's a reason there. All right, so can have also this one. So that is it on question 3. Then 3, question 4. Okay, that's where we had a lot of marks there, 30 marks. All right, anyways, let's see. 4.1, given that ABC, this triangle ABC, given this triangle below, determine the size of x. X is an angle there, angle X. What type of a triangle are we given? An equilateral triangle, where we do understand that these angles will be equal, all of them. Equilateral triangle. So meaning to say each angle be 60 degrees. Or you can add x plus x plus x, because they will be equal. So that's 3x. If you add these x's that you're given, because each angle will be equal. So x plus x plus x is supposed to give us what? 180 degrees. So that's it. We add 1 plus 1 plus 1, which is 3x. That's 180. Divide by 3 by 3. So x is 180 divided by 3, which is what? 60 degrees. An equilateral triangle, you do understand that way, that these angles, they are equal. So you can form an equation, you solve your equation for x, you know that it's done. Or you can just use the properties of what? An equilateral triangle, that each angle is supposed to be what? 60 degrees. On question 4.2, given that the triangle that we are given here is XYZ, determine the length of y from this triangle. There is 70 degrees, there is 70 degrees there. So what does it tell us? It tells us that the sides that are opposite these angles, they are equal. Sides opposite equal angles. So y automatically is equal to what? 7 centimeters. These are sides opposite what? Equal angles. Sides opposite what? Equal angles. All right, just like that, we can attempt our question. 4.3, we are given that in this diagram below, AC, A to C, it is the same as C to E. Prove that. All right, there's an angle also, angle A, this angle, and angle C. Then prove that these two triangles are congruent. So guys, already we can see that angle C1 is equal to angle C2, vertically opposite angles. So angle A, we are already given, it is equal to angle E. We've got sides already given, guys. We've got sides that are already given. AC is equal to what? To CE. That's given. It's already given. The only part that you are working with is this angle C. Angle C1 is equal to angle C2. Those are vertically opposite angles, remember. So it's a condition for these triangles to be congruent. Angle, side, angle. We're talking about that, how we saw that they're the same from the angle to the side to the angle. So therefore, these two triangles are congruent. Triangle ABC is congruent to triangle what? DEC. All right. Angle, side, angle. It's a case of congruence. It's a condition of our congruence. Remember when we listed those conditions before. All right, just like that. On question 4.4, triangle ABC and these ones, they are similar. Remember our sign there? Similar. Similar figures are equiangular, and also the ratio of sides is the same throughout. So determine the value of x. X represents what? AB. We can use ratio of sides, proportion. Ratio of sides, which is equal throughout. AB over what? The corresponding side, which is DE, is supposed to be equal to BC over the corresponding side, which is what? E to C. This must be equal to AC over the corresponding side, DC. As we need to calculate AB, which is representing what? X. So AB there. Over DE, we are given that DE. Do you have any ratio that is complete? BC, we have it. All right. Over EC, we have this one is a complete ratio. We also have AC over, AC is there. Over DC, it is also there. So guys, there we're going to use anyone that you want to use. Anyone that you want to use. So in this case, I'm going to take these two because we have got that one. So AB represents what? Represents X over DE. This is our DE, which is 12. That's equal to BC. From B to C, that is 2. Over EC. From E to C. This one from E to C, that is what? That is 9. All right, so this one, the way that it is, with the way that it was supposed to be, guys, here it was wrong because this one of AC, if you take AC is going to be 3 over DC, which is 6. That was going to be 1 over 2. So that was a mistake in terms of the values because if you check here, AC, yes, it is given. It is what? 3 over DC, which is 6. The ratio there is not the same because if you take these two, they are not the equal, guys. Remember, I say proportion, ratio of sides is equally the same. So according to their presentation of the similar figures and the way that we are given these values later on, they do not correspond, these two. So when you are under an exam condition, this one, it is actually an error from the exam, this one, from them, the examiner on their own. So you can leave it when it is like this, or you can use one of these ratios. You can write an error, then you take one of the ratios that you're given. So for our understanding of mathematics, guys, we can say this one cannot be simplified because these two ratios, these two cannot be different. Remember your proportion. If they are similar here, if they are similar, ratio of sides is supposed to be what? Supposed to be the same. So we're just going to ignore that one for the sake of our revision. Then on 4.5, determine the values of x and y from the diagram below if AB is parallel to DC. If AB is parallel to DC. All right, remember, if these two are parallel, it simply means when we have got an angle of maybe 100 degrees here, this one is going to be 80 degrees. All right, that is our understanding of the angles. But if these ones would be parallel, for maybe you are referring to a parallelogram now, this angle and this angle will give us the same property of 100. So in our case, they didn't give us also the correct or the full information of the diagram in this case. You see, sometimes in exam, this is what you face. And you'll be wondering, how can I answer this question? How is that possible? You're now working with an assumption. It was supposed to be given these two also parallel. BC being parallel to what? To AD. When it is like this, we can say opposite angles are what? Are equal. So in that case, we can equate angle A to angle C as opposite angles are being equal. We have an equation that we can solve that 3x plus 15 degrees must be exactly the same as what? 5x minus 40 degrees. So sometimes it's exam, they give you another concept, which is, they give you another diagram, which is not having full information. Then you'll be like, guys, what am I supposed to do? Just work out as many questions as you can so that you'll be able to figure out even the mistakes that are there in your examination. All right, 3 minus 5, that's negative 2. Minus 40 minus 15 was going to give us minus 55 degrees. So dividing by negative 2, we can say our x is 27,5, provided that we had a condition also that AD is parallel to BC as it was supposed to be given, as we're going to have our x as 27,5. And these diagonals bisect each other, so therefore we can take advantage that y and 16 will be equal to each other. So y is equal to 16 centimeters, since diagonals bisect each other in that consideration each other. These are the properties of a parallelogram that you're now using. All right, so let's do revise. Many questions. Another part of the question, we're given that angle XYZ is 100 degrees. XYZ is 100 degrees here. And there is angle ZYP, which is 20 degrees. Determine the size of X and Y. Also take note, there are two lines that are indicated on our diagram here. They are equal. So we do understand angles opposite these sides are supposed to be equal. So meaning to say this is X. They are equal. So we are saying to determine angle X, Y, Z, X, this angle Y, Z, X is equal to X. This one, it is equal to this one. These are angles what? Opposite equal sides. Angles opposite equal sides. So if they are equal, we can form an equation since angles in a triangle add up to 180. So you're going to have x plus 100 degrees. We equate it to what? 180 degrees. Angles in a what? Angles in a triangle. Angles in a triangle, remember they add up to 180. So x plus x, that's 2x. Take the 100 to the other side, that's negative there, 180 minus 100. So 2x is going to be 80 degrees, divide by 2 by 2. So that's 40 degrees. All right. Or you can simply 180 minus 100 over 2. X is equal to 180 degrees minus 100 degrees over 2, just like that. You are going to get the same answer there. All right. Then with this, we can also solve for y there, because we have got what? The straight line concept. Remember, this is 40 degrees. This is also 40 degrees, as I mentioned before. So angles what? On a straight line. Angles on a straight line. Sorry for that. This one. Angles on a straight line. So x plus y is equal to 180 degrees. Angles on a straight line. Angles on a straight line. We have already calculated our x, which is what? 40 degrees. So it means 40 plus y is 180 degrees. So solve for y in that case. Y is equal to what? Take this 40 to the other side. It was going to be a negative there. 180 minus 40, which is 140 degrees. All right. So many ways, or you can use the vertically opposite angles. Another way to find this y here, remember we say this is 40 degrees. So to find y, we can use vertically opposite angles. That was another way to find angle y. Y is equal to 100 plus 40. 100 degrees plus 40 degrees. That's the exterior angle. Exterior angle equal to what? Sum of what? Opposite interior angles. Remember that. So y was going to give us 140 degrees. Same answer as well. So it is in your hands how you answer these questions. Right, 4.7, we are given a diagram, and that is if BC, this one, is parallel to VW, if they are parallel, and angle A is 90 degrees, even though it does not look like a 90 degree, but they are saying it is 90 degrees there. Determine the size of X and Y. Okay, let's see our X and Y there. what can we do? We can start with y there because x and y, they are equal. Those are corresponding angles, guys. Remember your parallel line where we form F. These are corresponding angles. We are forming an F like this. One is inside, one is outside. So those are corresponding angles. X is equal to y. So if I find one of these, I'm done. All right. Those are corresponding angles as we are given VW parallel to BC. All right. Let's see. There is an angle of 141 degrees here as an exterior angle of the bigger triangle ABC, of this bigger triangle ABC. So that's the 141 degrees is equal to what? The sum of the opposite interior, the 90 degrees at A and the Y that we have at B. So we can form an equation to find Y there as 90 degrees plus this Y there is supposed to give us what? 141 degrees, the exterior angle of what? Of a triangle. That is equal to the sum of opposite interior. So let's find y from there. Take the 90 degrees to the other side. It was going to be a negative. So that's 141 minus 90 degrees. So y is equal to 51 degrees. When y is 51 degrees, automatically x is what? 51 degrees, as I said on this part that x is y. Those are what? Corresponding angles. So automatically our x is also 51 degrees as well. All right. So that is how we can work out these questions. Just try to revise, guys. All right. Study the diagram below. Classify A, B, C, D with at least one reason. So A, B, C, D, you can see that these presentation on its own, straight line, and these ones intersecting, meeting each other at 90 degrees, bisecting each other there. All right. That means we can work with what? A square. All right. A square does that. Remember the properties of a square. So thus we have got diagonals bisect each other at what? At 90 degrees. Diagonals. And also these ones. Each angle is 90 degrees horizontal and vertical line. So you can work with the diagonals bisecting each other. We can talk about each angle. Each angle is what? Is 90 degrees. That's vertical horizontal line concept being perpendicular. Or we can talk of the diagonals bisecting each other. I mean diagonals bisecting each other at, you must mention at 90 degrees. That must be part of your indication at 90 degrees. If that one is not presented, then it means it's going to affect. You must specify at 90 degrees. All right. Anyways, let us see 4.82, the size of ADF. All right. The size of ADF. ADF, this one. So what is going to happen is that the square, these are 90 degrees, and these diagonals, just like a rhombus, they bisect the vertex angle there. So meaning to say the vertex angle at D will be subdivided into two equal parts. So that will be 45 degrees concept. All right. That will be at an angle of what? Of 45 degrees. This will be bisected into two equal parts. Or we can use, all right, what can we also use? Let's see. Another way. ADF, this one. We can try. All right, still it's going to be something like that is from the previous case. All right, anyways, that is what we can just use there. We do understand diagonals bisect those vertex angles. So that's 90 divided by what? 90 degrees divided by 2, which is what? 45 degrees. As we do understand that diagonals bisect what? They bisect the vertex angles. So if you understand that, You're done. Angle that will be there. If it is 90 degrees, to be bisected into two equal parts, just like the properties of a rhombus. So that is it, guys. Let us do revise as many questions as we can as we are preparing ourselves for the exams that we are going to have in days to come.